Okay, so improvement 2 on problem 14 proved a little bit more difficult than I expected in the last video, so we're going to look at solving it this video. So what I want to do here, when I'm pulling from, if you haven't already seen the previous videos, by the way, go watch them, this won't make any sense without them. What I want to do here is, when I add to this dictionary, I want to be able to pull from our list, so our numbers in chain list. Now, I want to be able to hit this adding a dictionary every single time we find a solution. So I'm going to pull this over to outside of this while loop, because this while loop, once this is finished, we know we've actually found the solution, and therefore we can start adding to our dictionary and appending and whatnot. So yeah, I'm hoping this right here should fix that problem. We'll see now, I guess. The longest chain is 20, the number produced it was 9. Yeah, that there looks promising. Now, 20. 21, the chain that produced it was 18. So, if I now change this to a 20, there we go. Okay, so that seems to fix that problem. It is now working again. So, right here is where I'm going to be pulling from the list and adding to the dictionary. So I'm going to say for I in numbers in chain, I'm going to say print I. So we're going to see what numbers are actually in the chain. You can see there's actually some huge numbers. Let me just drop this down to 4. This will be our test number, because obviously 3 is the first one that I found that actually goes up in size to start with. So if we print I, we get yeah, here. Okay, so one of the problems is that a problem going wrong? No, I think that's right. If I just, each time I pass through here, if I just print X, it'll tell us with the thing to let me know where it is. So X is 1, there was nothing in the numbers in chain because that exited straight away. Now X is 2, 2 went in the chain. X is 3, 3 went in the chain, then 10, then 5, 16, 8 and 4. Now what I want to do is, I want to work through numbers in chain backwards, and I want to say 4 is equal to, okay, so what I'm going to do here, I'm going to get rid of this print, don't need that anymore. Now, I'm going to go through this list backwards. So for I in numbers in chain in reverse, print I. So you see here we do actually get everything backwards, the 3's at the end, and we start with the 4 right here. So we want to take these numbers and we want to add them to our dictionary in a way that we keep track of the length of them. So for example, the last number to get added to the list, we know that number is equal to our current chain. The length of that one is equal to our current chain plus, no, sorry, minus 1. Am I doing this right? I might actually have to go through backwards. So what I'm going to do is I'm going to say the length. So I'm going to print the length of, and then a number is, and then a number, length of chain 4. This is this dot format, and now I want to see what these numbers need to be. So the length of a chain, one of them is going to be I, and one of them is going to be looked up in the dictionary. So the length of the chain for I is, and then this one's going to be looked up in the dictionary, so it's going to be, actually it's going to be looked up, the current chain is probably okay now. So current chain, now current chain. So I'm going to move all of this down to below here, because then I stop having to use this. Is it gone? The current chain here is used. Now I'm going to edit this current chain value down here. That's why I've dropped it just below that. I'm going to say current chain minus equals 1. Now let me try this. So I'm going through it backwards there. Now if I try not going through it backwards, because I don't actually think I need to, I think that's where it's gone wrong. Okay, so this has worked. So if I get rid of this, this has been way harder than I expected it to be. So what I'm doing here, I'm printing the length of the chain for something is something, that something is I, and the other something is current chain. Now current chain is going to go down, so when we're adding to this line here, this is hopefully where we're up to so far with understanding. So hopefully people understand that adding the x key and giving it the value of current chain, that works. Now what I'm doing is I'm saying the first thing you added to the dictionary was the first step after x, so it was one step in from x, so a one step shorter chain. So if the chain for x was 10, then the chain for the first item in the list would be 9. So what I'm doing is I'm saying for I numbers in the chain, we're gonna add them all to our dictionary that way. So I think actually I can get rid of this line. If I just keep that in a sec, I'll show you why I can get rid of that line. So if I print dictionary, you'll see. Oh, okay, so I haven't actually added to the dictionary yet. Let me add to the dictionary now. So dictive non Collatz. Actually, we don't want to do it there. We want to add it at the top right here. So dictive non Collatz. So we're going to say I'm going to say that's equal to current chain, I think. So you see 3? Yeah, this has worked. So we've got 3 has a value of 8, and we've got then 10 has a value of 7, because remember 10, when you collapse that, it goes up to 10 first. Times by 3 you get 9, you plus the 1 you get 10. So you'd expect 10 to have a one shorter chain than 3, which it does, you see right here. Then 10 goes to 5, so that's going to have a one shorter chain than that, so 5 goes to 6. 5 then goes to 16. 16 has 5 because there's 1 less than 6. But you see this is actually working. If I get rid of this, is this now going to break then? Because I was expecting something else to happen there. So what has that got rid of? Oh, okay, so it's just got rid of the 1 1 thing. If I just put in our dictionary 1 1, does that bring it all back? Yeah, so I'm gonna actually keep that line out then, as I would imagine I might run into problems trying to add the same value twice. So if I get rid of all these extra lines that aren't needed, actually I'm going to keep that one because I want to actually print this dictionary out. Actually no, I don't, I'm already printing it. I'll print it right here. Now I'm just going to comment this one out. I'm also going to comment this one out. I'm going to change this number to a 10. Save. I'm going to run. So the longest chain was 20, the number produced it was 9. Now is that right? 2 needs to be 20. Oops, wrong one. Yeah, there we go. So we're getting matching answers now. Now if I make this number 1,000,000 and I make this number 1,000,000, so this one we know is right. This is going to give us our thing to test against. So we'll run the first one again. This should be about 5 or 6 seconds, as we've run before. Now, are we going to get an improvement with our new one? And are we even going to get the right answer? Okay, so we got the right answer and it was an improvement. I'm pretty impressed with that. I'm happy with that. Now, there's a few improvements you can make to this on top of this. For example, once we... So I'm not certain how you do this. This is why I'm not adding this, and this is why this small mini series of like problem 14 is probably going to stop right now. But basically, the only way to have a number 2 appear in your chain is by getting to the number 4 and then the number 4 halving to 2. The only way to get to a number 4 is by getting to the number 8 and the 8 halving to 4. So there's a few numbers that like you're only going to need in your dictionary for a short time, and then you can remove them to keep your dictionary shorter. Because if I add in, so if I show you my RAM usage now, and now I make this number, if I just keep it at 1,000,000 for now, and we run this, you see that RAM usage, you see that going up now, so it went up by about 200 meg. I just keep running this so you see it's consistent. So you see it goes up by 200 meg. Now if I put another 0 on the end of this sequence we're looking at, you're going to see that RAM usage go up and up and up and up. The reason being that we're keeping track of all our values in this huge dictionary, and obviously that needs to be stored somewhere. So you see that RAM being used more and more and more. Now obviously eventually I'm going to hit all my RAM used, and this code will fail because of that. So we're going to need some way of trying to keep the dictionary short if possible. You see there it now worked, so that number wasn't too big. But you can see like we might run into problems with RAM usage because we're keeping track of all these different numbers in the dictionary. So we could just do some sort of clever like selective adding of like numbers that are never going to get found, like never going to be needed to be looked up. We could just not add them to the dictionary. So for example, what you could do is you could say if the length of the chain is 100, then add it, and if not, then don't worry about it. We could just afford the computation time to go through that chain if it's not too long. There's quite a few clever ways you could add stuff to that. There's probably a lot cleverer than what I've just suggested, but yeah, if you've got any ideas for that, let me know in the comments below. I might take a look at it if I can come up with some good ideas for it, but don't be expecting it. So that's going to be it for this one. Quite happy I solved that problem. I can't believe the problem was as simple as just pulling out of this while loop. So yeah, if you like the video, like it. If you want to see more, subscribe. Probably going to get on with doing problem 15 now. So yeah, thanks for watching, and I'll see you in the next video.